Hi, in this video, we will talk about polar coordinate system then. Okay, so to the system that we are using, we call this Cartesian system, okay? So to the Cartesian system, usually we locate a point, for example, like 4, 3, something like this. Then we say that in this case right here, we have the x-axis, the y-axis. And then when we have 4, 3, basically it's telling me that when x is equal to 4, that means x equal to 4 basically is a vertical line that we have. Okay. And then y equal to 3. So y equal to 3 is a horizontal line that we have here. Okay. Then the intersections between x equal to 4 and y equal to 3 is the location, the point that we have. We name it ordered pair, right? 4, 3 then. Okay. However, to the polar coordinate system, okay, we are not working with x and y. We are actually work with the distance from the point between the point and the origins, okay, and also the directions theta. Okay. Okay, so this is kind of like the idea about the polar coordinate system then. Okay. So the polar coordinate system, our theta, okay. So again, first we are using a distance from the origins to the point is the distance r. And then theta will be the angle, okay, from what we call the polar axis, okay, to the line that we have, okay. So, and then r will be the distance from the origin to the point P, and theta will be the angle between the polar axis, okay, and the segment OP. So, okay, so then now let's see how do we actually again locate a point in the polar coordinate system now. Okay. Now remember, if we have again the point is R0. Okay. So what does this mean? Oh, maybe let us work with to make it more meaningful. Okay, maybe we start with B. Okay. So if I have point B, which is 3 and pi over 2. So to this one right here, when we have a point B is 3 pi over 2. Okay. So to this one, basically it means that you have R is equal to 3. Okay. And the angle theta is pi over 2. Okay. So then now, how do we actually work it out? First of all, I would like to again draw a polar axis. Okay. On this polar axis, I would like to put down the scale. So if this is 1 unit, this is 2, 3, 4, 5, 6, 7. Okay. And then now, what does this mean by r equal to 3? Basically, r equal to 3 meaning a distance between the point and the origin, right, is actually 3 units. So here is a 3 unit. But again, from here to here is also 3 unit. Okay. So you will see that if I connect all the dots together, basically r equal to 3 is a circle with the radius 3 then. Okay. So then this is the idea about r equal to 3 here. And now, if I have theta equal to pi over 2, in this case, meaning I have the angle, okay, from the polar axis, okay, is 90 degrees. So which is here, okay. Then this, it will be theta equal to pi over 2. Then to this point, meaning we are looking for the intersections between r equal to 3 and theta equal to pi over 2. So then this point right here, it will be point B, which is 3 and pi over 2 now. So this is the idea here, okay? Okay, then now, why don't you, let me try to locate the point A, C, and D, okay? We are going to work on the point D together. Okay, so then let us try to locate point A, which is 1, 0, meaning R equal to 1, and then the angle is 0. So then point A is here then. And how about point C? Okay, so now we have a negative angles. Then of course we know that the negative angle basically mean the angle is in a clockwise directions, right? So then in this case, this one right here, it will be negative pi over 3. And then to this one, it will be negative 2 pi over 3 here, okay? Then we have 5 units. So therefore, in this case, then we could have this one. This is 3, 4, and 5. So here, this will be my point C here, which is 5 negative 2 pi over 3 then. And of course, 6, 5 pi over 3, 5 pi over 6 is easy, okay? So we look at the angle 5 pi over 6, and then we have 3, 4, 5, and 6. Okay, so then this is the then this point will be point D, and then it is 6, 5 pi over 6 then. Okay, okay. Then now let's see how do we actually work with a negative R. Okay. So in this case, when we talk about the negative R, basically it is first we locate the angle, okay, the angle theta. Then what do we want to do is we are going to extend it to the other side of the origins, okay? And then we count the distance R, then this point right here, it will be negative R theta now, okay? So therefore, again, if this is R theta, then we extend the angle to the other side of the origins, and then counting the distance R, then this point right here will be negative R theta, okay? So then now, if I want to locate the point E right here, then the first, I would like to work with the angle 5 pi over 6 first, okay? And then now I would like to extend it to the other side of the angle, okay? And then now we would like to counting the distance 6, right? 6 unit, 3, 4, 5, and 6, okay? So then to this point right here, it will be the point E, okay? So then this point will be negative 6, 5 pi over 6, okay? Now, one thing is, to this point E right here, what I can do is, it is also equal to, okay, again, if I look at these locations, it is equal to 6, 11 pi over 6, right? It is also equal to 6 negative pi over 6, okay? Because again, this angle is also negative pi over 6 as well, okay? Why now? Let's see. If I want to find out that, okay, to this point right here, I would like to have a negative R and also negative angle, okay? Then how do we actually work it out? Okay, so again, I would like to work with negative R and negative angle. Okay, so then first of all, if I want to work with a negative R, negative angle, okay, so what do I need to do is I need to calculate, okay, the opposite of this angle right here, it will be this one, which is 5 pi over 6, okay? But we need to have a negative angle. So then in this case right here, I know that this angle is negative 7 pi over 6, okay? So therefore, this angle right here, it will be negative 7 pi over 6, okay? And of course, this one will be negative 6 then. Okay. So meaning any point in the polar coordinate system, we can actually write it as, okay, again, it will be what? It will be positive R, positive angle, positive R, negative angle, negative R, positive angle, negative R, negative angle, right? Again, they all have the same point, the same locations, okay? So each point, you have four ways to represent the point. Not like the Cartesian system, we only have one way to do this, okay? Okay, so then now, is there a relationship between the polar coordinate system and the rectangular coordinate system? Again, rectangular coordinate system meaning is a Cartesian system as well, okay? So of course, there must be a relationship because just based on this example right here, we know that to this point 4,3, we actually will be able to find the R right here. Okay, now how do we find R? Basically, we already know, right? Because it's in chapter 5, we already learned this. So this length is 4. This right here is 3. So basically, R will be, again, R squared is 4 squared plus 3 squared. So we actually will be able to find this R right here. And also, if I want to find this angle, then of course we could use tangent of theta is equal to opposite 3 over adjacent 4, isn't it? So again, to this point 4, 3, we will be able to rewrite this into R and theta. Okay, just use this. So then let's see in general. Okay. Okay, so in general, then of course, to this one, if we have x and y, that's mean in this case, if we have x and y, and then I would like to convert it to R and theta, we could actually using R equal to square root of x squared plus y squared. Okay. And then we could actually also use this angle right here to find the angle theta. We could use tangent of theta is y over x. Okay. And of course, to this one here, we also know that cosine of theta is equal to x over r. Okay. Also, sine of theta is opposite y over hypotenuse. Okay. In other words, to this one right here, we could actually solve for x. X is equal to r cosine of theta, and then y will be r sine of theta. Okay, we learned this in chapter 5 as well. Okay. Okay, so meaning right now, if I have r and theta, then we could use this to help us to find x and y then. Okay, so therefore again, if we have r and theta, we could use this formula x equal to r cosine theta and y equal to r sine theta to find okay, to the rectangular coordinate system. Okay, okay, so and now let's see how do we actually work it out the problem now. Okay, so to this problem, we would like to convert the polar coordinate system, meaning is r theta, to Cartesians x and y now. Okay. Then, of course, to this problem, we know that R is equal to 7. And the angle theta is 7 pi over 6. Okay. And we also know that 7 pi over 6 is in quadrant 3. Okay. Those are the information that we have. Okay. Okay. Then let us try to sketch. Okay. So basically we will have this one here. Okay. Is 7, and the angle that we have is 7 pi over 6. Okay. Then if I want to find x, it will be r cosine of theta. Okay. Then in this case, it will be 7 times cosine of 7 pi over 6. Okay. Okay. Again, 7 pi over 6 is in quadrant 3. So in this case, meaning the cosine of 7 pi over 6 will be negative cosine of pi over 6. Okay, again, pi over 6 will be the reference angle that we have. And then now, we know that cosine of pi over 6 is root 3 over 2. Then my answer will be negative 7 root 3 over 2 then. Okay. And now, how about y? Y equal to r sine of theta. So which is 7 sine of 7 pi over 6. Then it would be 7. Again, in quadrant 3, sine is negative, and the reference angle is pi over 6. So I will have 7 times negative 1/2. The answer will be negative 7/2. Then, of course, we are done. So in this case right here, 7 pi over 6. After we convert to Cartesians, it will be negative 7 root 3 over 2. Negative 7 over 2 then. Okay. Okay, so now it is your turn. Go ahead and try to work on the next problem. Okay. So r equal to 4. Theta equal to 7 pi over 4. And then this one is in quadrant 4. Okay. And the reference angle is pi over 4, right? We know those that's mean informations. And then x equal to 4 times cosine of 7 pi over 4. Okay. And 7 pi over 4 is in quadrant 4. And in quadrant 4, cosine is positive. Okay. So I will have 4. So 4 times root 2 over 2. Then of course my answer will be 2 root 2. And y equal to 4 times sine of 7 pi over 4. Then in quadrant 4, sine is negative, and the reference angle is pi over 4. Okay. Then it will be 4 times negative root 2 over 2. Then of course my answer will be negative 2 over 2 then. Okay. So and now I have 7 pi over 4 converted to Cartesians will be 2 root 2, negative 2 root 2. Okay. And now I would like to convert, okay, from Cartesians, meaning from xy, to polar, r and theta. Okay. Now to this, what I would like to do is first, I would like to locate the point. Okay, if it is in quadrant 1, 2, 3, or 4. Okay. And then second, we would like to draw, okay, the point, or we plot, okay. The point, okay, in the Cartesian system. And then the next one is number 3. We would like to find R and theta, right? So in this case, remember R equal to square root of x squared plus y squared. And the angle we could use tangent is y over x. But mainly, maybe we could find the reference angle and then use the reference angle to help us to find theta then. Okay, so this is kind of the idea then. Okay, so then now we know that -4, 2 is actually is in quadrant 2. Okay, so -4, 2. So we have this point. And then now what we want to do is we would like to find the R, okay, and the angle theta. Of course, to find the angle theta, we could find the reference angle first, right? Okay. And now number 3, okay, let's see. So we have R equal to square root of -4 square plus 2 square. Then I have 16 plus 4. And then square root of 20 is equal to square root of 4 times square root of 5. So then my answer will be 2/5 then. And now, second, I would like to find the theta bar, okay? So I have tangent of theta bar is equal to the absolute value of y over x, which is equal to 1/2. And theta bar will be the tangent inverse of 1/2. Then, of course, in this case, my theta will be pi minus tangent inverse of 1/2, okay? Okay, now remember this answer right here, it will be the exact, okay, answer. If I want to, again, rounding, right, approximation, we could put it in the calculator. And then we find out that this angle is 2.6779. Okay. Now remember the angle that we are finding is actually is in radian. Okay, so then now we could actually my answer here, it will be the point -4, 2 converted to polar, okay, to our theta, it is 2/5 and 2.677. Okay. Then this is the answer that we have. Again, we convert from xy to our theta then. Okay, then now go ahead and try to find, work with the next problem. Okay. Now the next problem, I would like to find the exact answer. Okay. Then let's see how we figure out the problem. Okay. So again, -5 is in quadrant 3. And this is the R. This will be the angle theta. Okay. And of course, we could find the reference angle is here. Then R is equal to square root of -5 square plus -5 square. So I will have this one is 25 plus 25. So I will have again 2 times 25 here, right? Okay. So then opposed to this one, I will have 5/2 then. And now the tangent of theta bar is the absolute value of -5 over -5, which is 1. And of course, in this case, theta bar will be pi/4. And theta, it will be pi plus pi/4. So we have 5 pi/4 now. Okay. So again, Cartesians is -5, to polar, which is 5/2 and 5 pi/4. Then now I would like to show how we actually use a calculator to help us to sketch, okay, the polar equations, okay. So, okay, so after you turn on your calculator, then again, the first step is we would like to click on mode, okay? And then now we are going to select first, the angle must be in radian, okay? And then now the next one is we are going to choose polar, okay? So if you are using the TI-83, then you just need to select POL, okay? This one, okay? Put enter. Okay. Now, once you put enter, when you select polar, then if you click y=2, you will see that instead of y=2, then now you have r=2 now, okay? And now what we need to do is, for example, number 5, we would like to input r=3 cosine of theta. So we are going to have 3 cosine of theta. Again, the theta is actually the same button that you are using for x. Okay. Okay. And now maybe let us try to go to zoom and then choose number 6. Okay. Okay. Now it seems that in this one the graph is look like an ellipse, but actually we could use this zoom right here to make it number 5, which is zoom square. This one will actually adjust the scale that we have, okay, to make it the scale just like the rectangle scale that we have here. Okay, so then actually the graph should be a circle, okay, with the diameter is 3. Okay. Okay. Okay, so in this case, then you will see that the graph of this one is this is X, this is Y, okay. And then to this one. We have a circle with the diameter is 3. And then to this one here is 1.5. This is 1.5 negative 10. Okay. So then now try to see if you could use your calculator to actually to help you to sketch the 3 times sine of 2 theta then. Okay. So then now let me clear this. So I have 3 times sine of 2 theta. Then now if you grab it, you will see that it's just like a flower with 2 leaves. Okay. So then maybe we could zoom it in. Yeah, this. Now, what if I want to, again, now you see, we could be more creative then. I would like to graph R equal to 3. Okay. And remember, R equal to 3 is a circle, right? So when I grab this, okay, then maybe let me zoom it in a little bit, zoom it out, right? So number 3. Okay. Then you will see that this is what happened. Okay. And what if, okay, if I change this one to 4 or maybe to 3, then let's see what happened. Okay. Then you will have 3 leaves. Okay. So again, you could play around with your calculator to see what you could get from what you have. Okay, from the polar equations now. Okay. So okay. So in this case, you have 4 leaves. Okay. So okay. So in this case, and remember, in this case, the distance from here to here is actually 3 units, okay? Because it is inside a circle with the radius 3, okay? Okay. Then now, we actually be learning how to we actually convert like from Cartesians, right? From polar coordinate to Cartesians, or from Cartesian to polar. And then right now, what if I have an equations, okay? That this equation right here is in Cartesian equations, okay? Meaning the equation contain only x and y. Will I be able to convert it to polar equations? Now, the polar equation is an equation that contain only r and theta, okay? So most of the time is we would like to solve for r, okay? To get the other side is depend on only theta. So we will have r equal to f of theta then, something like this. Okay. Okay. Then now let's see how do we actually do this. So if I have a Cartesian equations, how do we actually convert it to polar equations? The key is if you see x, you replace with r cosine of theta. If you see y, then you convert it to outside of theta. And then of course, if you see x squared plus y squared, then it is equal to r squared then, okay? Okay, then let's see how do we actually do this. So basically when you see y, then you change it to r sine of theta and equal to 4 times r cosine of theta to the square, okay? And then you have these in polar equation already, but the harder part is how do we actually solve for r, okay? Then let's see. So to this one, it will be r squared cosine square theta, right? Okay. Then if this is the case, if I want to solve for r, then what I need to do, the first step is maybe I can divide both sides by r. Then now I would like to solve for r. So therefore, in this case, I would like to divide both sides by 4 times cosine square theta. Then now I will have r equal to sine of theta divided by 4 times cosine square theta. Okay. Maybe let me rewrite this, okay, to r equal to sine of theta over 4 times cosine square theta. Okay. Okay, so now it's your turn. Now go ahead and try to work on number 8. Okay. Now, first of all, I hope that you are not going to change this one to r square because this is not x squared plus y squared, right? So therefore we cannot do this. Okay. So let's see how we actually work it out of problems. Then basically I would like to change x to r cosine of theta to the square minus r sine of theta to the square equal to r cosine of theta. Okay. Again, we convert to polar equations, and then right now we would like to solve for r now. Okay. Then I have r squared cosine square theta minus r squared sine square theta. Okay. And now we have a common factor. Okay. So we could take out r squared. So I have cosine square theta minus sine square theta. Okay. And then now we can divide both sides by r. Then I have r cosine square theta minus sine square theta equal to cosine of theta. And r equal to cosine of theta divided by cosine square theta minus sine square theta. Okay. So of course, if you remember that cosine square theta minus sine square theta is cosine 2 theta, then we could do this too. Okay. Okay. Again, to you, if you could get to the answer like this one, then it's actually good. Okay. But if you could get this, even better, right? Okay. Then now look at the next 3 example now. Okay, exercise. So right now we would like to have this from the polar equations, and then I would like to change it to a Cartesian equations. Okay, meaning now I would like to change it from r theta to xy now. Okay. And what we can do here is when you see r cosine of theta, you change it to x. R sine of theta, you change it to y. And then r square, you can change it to x squared plus y squared then. Okay. Okay. Then let's see how we break it out the problem then. Okay. Now to the first one, we only have r equal to 3 times sine of theta. Then what I would like to do, okay, now what if I multiply r equal to sine of theta, this equation right here, to r. Okay. If I do this, then I will have r squared equal to 3r sine of theta, right? Then in this case, we know that r squared is x squared plus y squared equal to 3. R sine of theta is y. Okay. And we are done. Okay. Then how about the next example? Okay. Now to this example, I'm not going to multiply both sides by r. The reason is, what if I square both sides? Then I will have r squared equal to square root of r cosine of theta plus 2 to the square, right? We square both sides. Then I will have r squared is r cosine of theta plus 2, okay? Then in this case, I will have x squared plus y squared equal to x plus 2. Oh, I hope that you notice that these two equations right here, the x squared plus y squared equal to 3y and x squared plus y squared equal to x plus 2 is actually, they are circle, right? Okay. Okay, then now, how about the last one here? Okay. Okay, so in this case, what if I have like using direct cross multiply, then I have r times sine of theta plus 7 cosine of theta equal to 4. Then distribute the r, so I have r sine of theta plus 7 r cosine of theta is equal to 4. Okay. Then in this case, we will have y plus 7x equal to 4. We have a straight line then. Yeah. So again, in this section, we learn a new coordinate system, right? The polar coordinate system. Again, I hope that you have fun, especially you could use a calculator to graph, right? The polar equations then.